Hello. Let's begin our class. Yesterday, I have updated the course website, and you can see the results of the midterm exam. You can see your grades in this link, and you can also find your answer paper in this link. And the file name is your student ID. And I also recorded a video to explain the midterm questions. And you can watch this video to find the answer of each question. And assignment 3 is announced on in the previous week, and I also updated the accuracy of assignment 3, and you can check the accuracy. And I will explain assignment 3. And three is about a decoder. A decoder means the input. A decoder means we want to convert some input information into another into the required information. And for this assignment, we assume the input is a sequence of bits. Each bit is 0 or 1, so the input is a sequence of zeros or ones. And we want to, and the program output. Program output are color informations, and you should your program should output corresponding message for each bit encoding. And this assignment has 5 types of bit encoding, and the following is the rules. And 0 corresponds to red, 1 corresponds to green, and 100 corresponds to blue, and so on. So let's see one example. Suppose the user inputs a sequence of bits, and then your program need to output the corresponding color information. And you can see this figure. So we decoded from the leftmost digit. So we begin from this digit. So we begin from the leftmost digit. This digit is 1. So if you look this table, you find the output can be blue, pink, or orange. And so in order to find which one, so we need to proceed to the next digit. The next digit is 0. So the next digit is 0, so we still have 3 possibilities: blue, pink, and orange. And we need to proceed to the next digit. So we proceed. The next digit is 0. And now we know we have 100, and 100 should output blue. So when you So when you go to when you are at this digit, then you should output blue. And then we move to the next one. The next digit is 0. And now we have two possibilities. Uh, the output can be red or green because the first digit is 0. And then so we need to see the next digit. Then if you check the next digit is 0. So when we at this position, the program should output red. And you can follow in similar process you can follow similar process to process the whole sequence. And here I also provide more input-output samples, and you can use these samples to test your program. And your program output should be exactly the same as the outputs provided here. And you should note the spelling should be exactly the same, including the case. The first character is uppercase. So you should ensure the output are exactly the same as the one provided here. And I also provide a code template, and let's see the code template. And I suggest you start your assignment from this template. So first, here I use string. String is a data type. You can view string as one character array. So code is a character array, and Cin will read user inputs into this character array. So this character array is character array is like this. So the character array is enclosed by double quotes, and our inputs are ones or zeros. Then we can then I declare I is index because we want to access array elements. And below is a while loop, and inside this loop we will access each character. So for example, you can print each character. So here I print each character, and you can try to run this program. Because I didn't update the index. So you see infinite loop. So here I should also update the index. And you see that this while loop will print each element in this character array. And this character array is the input. And then you can process, you can start to perform decoding. For example, if you want to check if you want to check whether the digit is 0 or 1, you can use this. You can use the equality operator, and each element is a character, so you need to use a single quote. So the data type of this element is not an integer, it's an character. So here you should write. You should use a single quote to use a single quote to enclose the digit. So you cannot write equal to 0 because the data type are different. Now you see that I compare if digit is 0, then I will output 0 followed by a space, and if the digit is 1, I will output 1 and followed by an underscore. So you need to properly update the index. You need to properly update the index and to output the corresponding information. And here I have one suggestion. You can use the at function to replace the bracket. So here for one example, if you here suppose we use I+1, then this will cause this will cause index out of range, because if I is the less if I is the last position, then I+1 will cause index out of range. But when you run this program, you will find the program the program looks very normal. You didn't observe any error message. So, but if you replace the bracket with the at function, this function can detect index out of range. So I replace the bracket with the at function. And when you run this program again, you will notice that when you run the machine code, the out of range exception is thrown, because this function can detect index out of the range. So I suggest you to use this function to replace the bracket, because this function the at function can help you to detect index out of range. If you use bracket, this notation will not detect index out of range. And if index out of range occurs, then your program will have a runtime error. And in this case, your accuracy will be 0. So you need to ensure that no runtime error occurs. And this assignment is about decoding. And if you are interested about the motivation of encoding and the decoding, you can read this article. This is about communication theory. So the decoding and the encoding is widely used in communication systems. We still have 2 assignments, and next week I will post assignment 4. And this week we will learn function parameters, which are called by value and called by reference. We have 2 mechanisms, and we will also learn function overloading. And let's see the slides. And in this chapter, we have 3 parts. The first part is about the mechanism, about how to pass the parameters. And we have 2 mechanisms. The first mechanism is called by value. The second mechanism is called by reference, or you can mix the two mechanisms. And the second part is about function overloading. Function overloading means we can define functions using the same name, but with different parameters, different inputs. The third part is about how to test and debug your program, and we will introduce some methods to test your programs. What we learned so far are called by value. So I will use one example to illustrate this. Let's see this example. We have one function, and this function is to compute the fee based on the two inputs. Now, the two inputs are hours worked and minutes worked. So this function has two inputs, and we want to know after this function call whether the inputs will be modified. For example, after this function call, will minutes be modified? So here I make a function call, and we want to know after this function whether after this function call whether this variable will be modified. And because this variable is passed as the second input, and this variable will be modified by this line. So 30 will be passed to this input. So the value of this variable is 30, and this line 30 times 60 is 1,800 and plus 30. So this variable is modified. We can see the outputs. We see this function call does not modify minutes. This function call does, because the value of minutes remain the same, remain 30. So this function does not modify the input variables. This is because what we use is call by value. This function is call by value. Because this variable is a local variable, so this variable is different from minutes declared inside main function. So the two variables are independent. And when we make this function call, the value of minutes is copied to the local variable minutes worked. So when we modify the local variable, this will not affect the variables declared in the main function. So when you modify the local variable, this will not affect minutes. And this mechanism is known as call by value. So call by value means copy of actual arguments. So call by value means you copy the value of this variable to the local variable declared in this function. So only local variables are modified. And this is the default mechanism for C++ functions. So what we learned so far are all call by value. What we learned so far are call by value. And if you want to modify the input variable, then you need to use the call by reference mechanism. And to do this is very easy. You simply modify your function definition. So if you want to modify the parameter input parameter, then you can add the ampersand operator in the function definition. Now suppose I want to modify minutes, then I just need to add the ampersand operator after the data type. And you will know that after this function call, the value of minutes is modified. Oh, its value is hours worked times 60 plus minutes worked, so it's 630. So the value of minutes is modified because we use call by reference. So if you want to modify input arguments, input parameters, then you can use the mechanism of call by reference. So for this mechanism, chorus data can be modified by code function. And you need to use the ampersand operator after data type in the parameter list. Here is another example. You can use call by reference. Now suppose we want to swap values of two variables. Now suppose we have two variables, A and B, and we want to swap their values. To do this, you need one temporary variable. You need to memorize the value of one variable, and then I assign B to A, and then I assign the value of A to B. Then in this way, you can swap the values of A and B. So we see that after the statements, the A and B are 3 and 5. the values are swapped. And now suppose we want to write a function to perform this operation. So now suppose we want to write a function. Then we make a function call. And you notice that after this function call, the values of A and B remains the same because we use call by value. So this will not affect input variables. And if you want to affect input variables, you need to use call by reference. So to do this, we add ampersand operator after the data type. So here we use call by reference. And then you will notice that after this function call, the values of A and B are swapped. So here is one example about when to use call by reference. This slide shows some details about call by reference. When we use call by reference, actually we send the memory address of the input variable. So when we use call by reference, we pass memory address. So memory address is the memory location of the argument, of the input argument. You can skip this page because this is only some terminology. And you can also mix the use of call by value and call by reference. So in this example, this function has 3 inputs. The first input is passed by value, while the remaining 2 inputs are passed by reference. Because for the remaining 2, we use the ampersand operator after the data type. And this example is to test whether you understand the 2 mechanisms. This function call will modify the inputs. The inputs will be multiplied by 2. And so after this function call, you see the the second and the third parameters are multiplied by 2, while the first parameter remains remains the same because the first parameter is called by value, is passed by value. Here I summarize the situations about when to use call by value and when to use call by reference. Now suppose you declare you define a function, and its input is src. Here I use the string data type, and actually you can replace string this data type with any data type you want. So if you declare a function like this, this function is call by value, and call by value means a copy of this src is created. So any changes inside this function will not affect the original string. But when you perform copy can be slow because you need to copy each character in this string. And the second declaration use call by reference. So here we use the ampersand operator after the data type. And if you perform modifications to src inside this function, then this will affect the original string. So if you need to modify the original string, then you should use call by reference. And in next page we have the third declaration, and in this declaration we add const. We add const before the data type, and this is known as call by const reference. If you use this declaration, then this function cannot modify the original string. So you might wonder, this declaration is very similar to the first declaration because both declaration cannot modify original string. But this declaration has one benefit. The advantage is that no copy is made. So this declaration is more efficient than call by value. So if you want to pass one large object, then you can use this function declaration because this declaration is more efficient. And actually, this declaration is widely used in C++ libraries. For example, for the string C++ string library, here is one function implemented in this library, and let's see its function declaration. So, for example, the insert function. This function has two inputs. The second input use the second input use call by const reference. We see that here is the ampersand operator after the data type, and before the data type, here is the const modifier. So this means this function cannot modify the original string. So if you want to efficiently pass in arguments, then you can use call by const reference. The fourth one is about it's still call by value, but we add the const modifier before the data type. And this is similar to call by value, but with one additional constraint. We cannot modify the local variable src. src is the local variable for this function. And if you add the const modifier, then you cannot modify the local variable as src inside this function. And we rarely use this declaration because we don't care about whether the local variable is modified. So this declaration is rarely used. And we have finished the first part. So the first part is about the mechanism to pass parameters. So the second part is function overloading and default arguments. So let's see the second part. Function overloading means we use the same function name, but with different parameter lists. And the function name plus parameter list is considered as function signature. And function signature is unique. Now we have one example. This example uses function overloading. We define two versions of the average function. The first average function accepts two inputs, while the second average function accepts three inputs. The two functions use the same function name, but their parameter lists are different. So this is known as function overloading. Then when you make a function call, if you pass two inputs, then this function call will refer to this version, this function definition, because this function definition match your function call. And if you made a function call with three parameters, then the compiler will refer this function call to the function definition with three parameters. So compiler will find compiler will find the appropriate function definition for your function call. And actually, this example is not a very good example to illustrate function overloading, because this example is a bit silly, because each version can only deal with a fixed number of inputs. If you want to compute the average of 4 numbers, you need to define another function. So this is very this is not a very you need to redefine the function if you use different number of inputs. So this is not a very good example about function overloading. And do you know how to write a function that can deal with arbitrary number of inputs? For example, the input can be six inputs or 10 inputs. Can you write a function to compute the average of the input arguments? And I think time is up, so let's take a break for 10 minutes. Hello. Uh, let's continue our class. Uh, Here is one example for function overloading. However, when you want to implement average, I think you should write function in this way. I will show how you can implement the average function that can deal with arbitrary number of inputs. Now suppose we want to write the average function that can deal with arbitrary number of inputs. For example, 5 inputs. Then you can consider use array. Use array because array can contain many elements. So if you want to send many parameters, you can consider using array. And so we can send array as function inputs, and we also need to send the array size. So to implement the average function, we can compute the sum of all the elements in this array, and then we return sum divided by size, and which is the average. Here you should initialize the sum with 0. And we can see that the average value of this array is 3. And you can modify the number of the elements. And if you modify array size, you don't need to modify the function definition, because this function definition can deal with arbitrary number of inputs. This slide is about the abuse using function overloading, and we usually only overload the same task functions, if a function perform different tasks, then you should not use function overloading. For example, this implementation does not perform the average operation, and so you should not use the function name average, because this can confuse someone read your program. This slide illustrates the details about function overloading. When you call a function, the compiler will try to find the exact match. So when you make a function call, the function will try to find function definitions that exact match your function call. So this is the first priority, and if the compiler cannot find exact match, then the compiler will try to find compatible match. Compatible match means the compiler will try to perform some type conversion. For example, the compiler might convert integer to double or double to integer. So if the compiler cannot find exact match, then the compiler will try to find compatible match. And we will use some example to illustrate this. Now suppose we define a function mpg, and both inputs are double variables. And now suppose we make a function call, and we pass two doubles. And then this function call is exact match, because the two inputs are doubles. So this function call exactly matches the function definition. And if you made a function call like this, the first input is integer, then and the second input is a double. Then this function call does not exactly match this function definition, and the compiler will try to perform typecasting, will convert the integer to double. So 5 will be converted to 5.0, and then after this conversion, the compiler will try to find compatible match, and the compiler will find this function definition matches this function call. So this is the details about function overloading. The next one is another function overloading example. Now suppose we overload func, and we have 3 versions. The first version accepts 1 integer and 1 double, and the second version accepts 1 double and 1 integer, and the third version accepts 2 integers. And if we made a function call like this, we pass two double, if we pass two doubles, then the compiler cannot find exact match, and so compiler will try to perform conversion. The compiler might convert integer to double. So the first function matches this function code. However, we still have another possibility. The second version, if you perform conversion, the second version is also possible for this function code. Actually, the third version is also possible. So this will cause ambiguity for this function code. And you can try to make an experiment to test when you make this function call, which function will be called. Now suppose I made a function call, then this function call should match this function definition. So the program should print 3. Because both inputs are integer. And if the second one is a double of a double variable, then this function call should match the first one. So the program should print 1. And if we modify the first one to a double, then we see that we have syntax error, because the compiler cannot determine which version to be called. So we have compile time error, because this function code is ambiguous. The compiler does not know which function to use which function, because both 3 functions are possible. The 3 versions can be candidate for this function code. So when you define functions, you should consider such case and avoid confusing overloading. I will skip the two slides because this is a more advanced topic. So I will skip this one. Next, let's see default arguments. When we define a function, we can provide default arguments. Default arguments means you can omit some. When make a function call, you can omit some arguments. and sometimes this will be convenient. Here is one example. Suppose we declare a function. This function has three arguments, and if you want to provide the 4 arguments, you can use assignment. You can use assignment to provide the 4 arguments. So if you don't supply the second argument, the second argument will be set to 1. And if you don't supply the third argument will be set to 1. This is the 4 arguments. So for this function call, because we provide all arguments, so the 4 arguments will not be used. And if you make a function call like this, we only supply two arguments, and the third arguments will be set to 1. And if we made a function call like this, we only supply the first argument, so the remaining 2 arguments will be set to 1. Here is the definition of the show body and function. So you can try to practice how to use the 4 arguments. Using this example. And we know that the order is important. The order is important because for this example, if we supply 2 arguments, and this means you give the first 2 arguments, and the third argument will be set to 1. So the order of the operator, the arguments are important. And if you want to give the 4 arguments, you should perform this in function declaration, not function implementation. So you see that in function, this is function definition. We do not give the 4 arguments. If you want to specify the four arguments, you should do this when you declare this function. If you don't use default arguments, you need to supply all the all the arguments. So if you don't use default arguments, you need to supply all the arguments. And if you use default arguments, you can sometimes you can omit some argument. And we have finished the second part. And next we will go to the third part. The third part is about how to test and debug your programs. And we have a lot of methods. The first one is to use cout. You can use cout to print the values of variables. And so you can trace the value of each variable. So this is we usually use this method because this method is the most intuitive one. The second method is you can use a debugger. Some IDE will provide a debugger. For example, if you use this online IDE, you will notice that this IDE has a debugger. You can use debugger to set some breakpoint, and the program execution will stop at the breakpoint, and you can print the values of some variables. So I will not. So if you want to use debugger, you can you can try to use the debugger provided by the IDE, your IDE. Next, I will introduce the third method. The third method is we can use the assert macro to validate some variables. And this assert macro is defined in this library, C assert library. So if you want to use this, if you want to use this macro, then you need to include the C assert library. This macro is defined already exists in the C programming language, and C programming language use assert.h library. And in C++, we will remove .h and add the C prefix. Now suppose we want to ensure that some variable is between 0 and 100, then you can use the assert function to ensure this condition. Now suppose we have a variable, we have the coin value variable, and we want to ensure its value is between 0 and 100. Then you can use the assert macro. So because the value is 50, so the assert has no effect, and the program will print hello. Then if we modify this value to 101, then the assert will have effect. And when you run this program, you will see that assertion failed because the coin value is outside this Boolean condition. So if your expression, so inside the parentheses is a Boolean expression. If the Boolean expression is false, then assert will then the assert will terminate your program. So if the Boolean expression generates false, then your program will be terminated. And we see that we see this error. So do you know this error is compile time error or runtime error? If you think this error is compile time error, please raise your hand. If you think this error is compile time error, and if you think this error is runtime error, please raise your hand. Nobody knows. This error is runtime error. This error is runtime error because we can compile. You can compile this. You can compile this program. So you can compile this program. So this means we have no compile time error. When you run this program, this error occurs. So the assertion fail is a runtime error. Because this error occurs during the runtime. So this is the runtime error. If compile time error occurs, you cannot generate the machine code. So now we can generate the machine code. So the syntax is correct. Compile time error is like this. For example, I omit the semicolon. Then when you compile this program, the message is compilation will be failed. Now we already we compile this compile this program successfully. So the machine code is generated, and when we run this machine code, the assertion, the assert macro terminate this program. So this is the this program generates a runtime error, and you know that this is, we also have the SC code. The SC code is not 0. This means this program does not terminate normally. And you can also separate this Boolean expression into 2 lines. For example, I can make to assert and now I separate this Boolean expression into two lines. The first line will check whether coin value is greater than 0. The second line will check whether coin value is less than 100. And because coin value is 101, so the second assert the second assert failed. And your program might have many asserts, and you can turn on or turn off all the asserts using this preprocessor. If you include this line in your program, then this will turn off all the assertions. So here n means undebug means no debug. So if you include this line in your program, this line will turn off all assertions in your program. So for example, I want to turn off all assertions, then I just include this line. And you see that assertions will be passed. So assertion will be passed. So the program prints cout statement. And if you comment out this line, then assertion will affect your program. So we can include this line to turn on or turn off all the assertions in your program. Next, we go to the fourth method to debug your program. We can use stubs and drivers. You can write a driver program to test your program. For example, I have written a function uni price, and I want to write a driver program to test this function. So the driver program is like this. We need to generate two inputs, diameter and price. So the driver program will let user input diameter and price, and then make a function call to the function we want to test. And this driver program will use cout to print the return value of this unit price. And if you want to repeatedly test this function, then you can input y, so you can perform another test. And if you want to finish this test, you simply input characters other than y. So this is one example of a driver program. This slide is about stubs. Stubs means you can delay the implementation of some function. So for example, I can delay the implementation of this function. So I simply return some value. Then you can write a driver program first. You can write a driver program first before you implement this function. And so this operation is known as stub out. You can stub out function. Stub out function. So that you can write a driver program first. I will show one example. Now suppose you want to suppose I want to write a driver program to test assignment 3. Suppose you have finished assignment 3 and you want to write a program to test your function. here is one example about how to test your assignment. Now suppose you write a function to perform decode. So the input is a string. The output is also a string. Here I use stop out to delay the implementation. I just return some string. And now we can start to test this decoder. Here is the input, a sequence of bits, and O1 is the corresponding output for this input, and we send the input to this function. This function will return should return the decoded information, and if the decoded information matches the answer, then this program will print passed. Otherwise, the program will print failed. So you can write the driver function like this to test your program. For example, if the output of decoder matches the answer, then the program will print passed. And you can use many input-output pairs to test your function. Here I just use only one input-output pair, and usually we will perform many tests, so you can use many input-output pairs to test your function. So like this, you can use the samples. So in this file, I provide 10 input-output pairs. So you can use these 10 input-output pairs to test your function. The last page is the fundamental testing rule. This rule says that you should test every function in your program where every other function has already been fully tested and debugged. And this is very important because you need to ensure every function is correct. Otherwise, there will be some bug in your program. And so I suggest we should always use the library. If the function if you want to use some function and which is already defined in some library, then you should use the library rather than to implement the function by yourself. Because the function has been have been fully tested before its release. So you can trust the library. And when you implement the function yourself, you need to. There might be some bugs in your implementation. So it is important to know the functions in the standard library. because you can save the time to implement the functions already defined in the standard library. And if you want to write your own function, you need to follow the fundamental testing rule. You need to ensure your function is bug free. And I think we can take a break for 10 minutes. Hello. I think we can continue our class. And we have finished we have finished parameters and function overloading, and we will introduce the next chapter, pointers and dynamic arrays. So this chapter has 3 parts. Pointers is widely used in the C programming language, because in C programming language, if you want to use the call by reference mechanism, then you need to use pointers. However, in C++, we don't rely on pointers, because we can use the ampersand operator to implement call by reference. However, the concept of pointers is important in C++, so I will still introduce pointers. The second part is about dynamic array. What we learned so far is static arrays. Static array means you cannot adjust array size, and in some applications we need to adjust array size, and in this scenario you need to use dynamic arrays. So the second part I will introduce how to create and how to use dynamic arrays. The third part is about classes, and I will delay this part until we learn the structures and classes. So I will introduce the first 2 parts first. What is a pointer? Pointer is you can view pointer as a data type, and the purpose of this data type is to store memory address. So for example, you want to declare a pointer, and this pointer is used to save the memory address of some variable. So I will use one example to illustrate the idea of a pointer. Now suppose we have one variable. So now suppose we have one integer variable v, and if you want to print its memory address, you can use the ampersand operator, and this operator will return the memory address of this variable. So here is the memory address. This is hexadecimal, because hexadecimal system, because this number begins from 0x. Now suppose we want to declare a variable to save this memory address, then you can use a pointer. So in this line, I declare a pointer. So you can view int star as one data type. So here you can view int star as a data type, and I use this data type to declare a variable p. And the purpose of of a pointer is to save memory address, so you can assign. So you can assign this memory address to a pointer. Next, I also print the value of p, and you see that the value of p is the same as the memory address of v. So we can use a pointer to deal with memory address. You cannot use integer variable to deal with memory address. Now suppose I try to use integer variable. This is not pointer. This is ordinary integer. I want to assign memory address to this integer. This will cause syntax error. So this will cause syntax error. Because in this line, if you try to assign some memory address to an integer, the data type, this conversion is invalid because the data type are not consistent. On the right hand side is a pointer, int star. On the left hand side is an integer, so the data type are not consistent, and therefore you cannot perform this assignment. This means you cannot treat memory address as an integer. If you want to deal with memory address, then you need to use pointer. So if you want to declare a pointer, then if you want to declare a pointer to one integer variable, then you use int star. And if you want to declare a pointer to a double variable, then you can change int to double. So for example, I use double star to declare a pointer p. Then p is declared a pointer to some double variable. And p can be used to save memory address of a double variable. And you can also declare multiple pointers in the same line. If you want to declare two pointers in the same line, you can use this syntax. Suppose I want to declare pointers p1 and p2 in the same line. You can use this. You can use this statement. We have two notations. Here we add a space between integer and the star. You can also add a space after the star. This is also acceptable. The syntax is also legal. So the position of the space, you can put space between data type and the star, or you can put space after the star. But we usually prefer to usually prefer to put space between data type and star, because this is more consistent. Because if you want to declare 2 pointers, the first this line is more consistent than the second line, than the second statement. So this slide emphasizes that pointer is used to save memory address, and memory address is one integer. However, you cannot treat a pointer as an integer because they have different data type. And in C++, if you want to deal with memory address, then you need to use pointers. I already introduced the ampersand operator. This operator is used to obtain the memory address of some variable. So if you prefix this operator before some variable, this operator will return the memory address of that variable. And if we want to retrieve the value the pointer points to, then we can use the dereferencing operator. The dereferencing operator is a star. So let's see one example about how to use the dereferencing operator. So here I declare a pointer p, and p points to the integer variable v, because I assign the memory address of v to pointer p, and if you perform dereference, if you write star p. If you write star p, this means you perform dereference. And if you perform dereference, then this will return the value of v, and the value of v is 10. So this line will print 10. And if the value of v changes, for example, if I modify the value of v to 5, then the value of star p is also changed. So you see that star p is 5. So you can view this assignment by the right hand side figure. When you assign memory address to P1, this means you create one arrow to integer V1. So when you perform this when you assign some memory address to a pointer, this will create one arrow to integer V1. So you can use this graph to visualize this assignment. And when you perform star P1, you will retrieve the value of V1. And if you can also modify the value of V1 via this pointer. For example, if I modify. For example, if I modify star P, then the value of V will be modified. The value of V will be 6. So you can use pointer to modify the value it points to. And so if you use the dereference operator to modify, if you use the dereference operator, then you can modify the value of P1, V1. So V1 becomes 42 in this example. Because star P1 and V1 refers to the same integer after this assignment. And in this example, you can combine the two lines into a single line. So you can declare a variable and also perform initialization. You can initialize this pointer to be the memory address of integer V. So you can combine the two statements into a single statement. This statement might be confusing for some beginners, because here star is not dereferencing. You should view int star as one data type. So you cannot treat star as the dereferencing operator. So in this line, star is not the dereferencing operator. So this star is different from the next line. In this line, star means the dereferencing operator. However, in this line, you should combine int with star. Here, int star is a data type. So in this line, stars does not mean dereferencing. Some beginners might confuse this. So you need to understand the meaning of this operator. When you declare a pointer, this operator does not mean dereference. You should combine the data type with star. So in this line, int star means a data type. Uh, so, uh, so, so this slide uh, provides this example, and you can combine pointer declaration and the pointer assignment into a single statement, and the meaning of this star operator is different in the in these two statements. Next, I will introduce pointer assignments. You can assign some pointer to another pointer. This is called pointer assignment. Here is one example, and I also provide some visualization to help you understand pointer assignment. Now suppose we have two integers v1 and v2, and we let pointer p1 points to v1, and pointer p2 points to v2. So after this declaration, we have this figure. We have this figure. P1 points to v1, and p2 points to v2. And the initial value of v1 is 5. The initial value of v2 is 2. Then we perform pointer assignment. We assign p2 to p1, and if you perform this operation, then we know that the arrow of p1 points to v2. So when you assign p2 to p1, you change the direction of this arrow. This arrow originally points to v1, and after pointer assignment, this arrow points to v2 because p2 points to v2. So after this pointer assignment, you change p1. Now p1 points to v2, and we can compare this statement with the following one. The following one assign star p2 to star p1, and this line is not pointer assignment. This line does not change any pointer. Let's see this statement. If you assign star p2 to star p1, then this means you modify star p1. Star p1 is this value. Star p1 is 5. Star p1 is 5, while star p2 is 2. And we assign 2 to star p1, so we modify the value of v1. So the value of v1 is changed from 5 to 2. So if you perform this assignment, you modify the value of v1. Originally, the value of v1 is 5, and you assign the value of star p2 to v1. So this statement is not pointer assignment because you do not change the arrow of a pointer. The direction of pointers does not change. So this is not pointer assignment. Next, I will introduce the new operator. The new operator can be used to allocate memory. For example, if you want to allocate the memory of one integer, then you can use new int. And this operator will return a pointer. So this operator will return a pointer to the allocated variable. So for example, if you allocate the memory of one integer, this operator will return a pointer to that integer. Let's see this example. This example illustrates how you use the new operator. Now suppose we declare two pointers p1 and p2, and because we do not initialize the two pointers, so the initial values are unknown. And if you use new int, new int to initialize p1, then p1 will point to the allocated memory space. So this is a pointer assignment. You assign some memory address to a pointer. So this b is a pointer assignment. And you can use the dereferencing operator to modify the value stored in this memory address. For example, if you assign 42 to star p1, then the value in this integer becomes 42. In this example, I print the value of star p1. We see that its value is unknown. It is some random number, because we do not initialize this allocated variable. And if you want to initialize the allocated variable, you can use parentheses. So if you want to initialize this integer, you can use parentheses. Now suppose I want to initialize its value to be 7. So now you see that star p1 is 7. Star p1 is 7 because here I initialize the allocated integer. So if you don't perform initialization, the value of star p1 is some random number. And next, suppose we perform p1 to, or you assign p1 to p2. Then this is a pointer assignment. So now p2 will point to now p1 and p2 will point to the same memory location. And if you modify, if you modify star P2, then this will affect the value in this memory location. So the value of this memory location is becomes 53. So we can practice how to use pointers by this example. In this example, I declare two pointers, P1 and P2, and I allocate the memory space of one integer to P1, and I also initialize its value to. I also initialize the initial value of this integer to variable to 42. So if you print star P1 should be 42. And then I perform pointer assignment. I assign P1 to P2. So P2 and P1 will point to the same memory location. And if I modify, if I assign 53 to star P2, then I will modify the value in that memory location. So you will find star P1 will be modified to 53. So we see that if you perform pointer assignment, then P1 and P2 points to the same memory location. And if you modify star P2, this will affect star P1. And if you remove pointer assignment, if you remove this line, the value of star P1 remains unchanged. The star P1 should be the same as this line, 42. And if you use new int to allocate memory space and assign the return pointer to P1, then you will create. Then you perform a pointer assignment. So P1 will point to the newly allocated location. Here is one example to illustrate how to use pointer to achieve the mechanism of call by reference. In C++, if you want to use call by reference, we add the ampersand operator after the data type. However, if you use C programming language, you don't have the ampersand operator. So if you use the C programming language, you need to use the pointer to achieve the mechanism of call by reference. And both functions will swap the values of its input. So both swap v1 and swap v2 will swap the value of the two inputs. v1 use pointer while v2 use the ampersand operator. And we know that if you want to use v1, you need to send a pointer. So if you want to use v1, the two inputs are pointer. So you need to use the ampersand operator to obtain the memory address of N1 and N2. And if you use V2, you don't need to pass pointer. You just pass integers. So the function code between the two versions are different because they accept different data types. So you can also try to practice this example by yourself. So after this function call, the values of A and B are swapped. And you can also call function 1. Version 1, you can also call version 1. And you need to send pointers. If you don't send pointers, this will cause syntax error. So if I want to use version 1, I need to send memory address. So you can use either version 1 or version 2 to achieve the call by reference mechanism. However, I will suggest using version 2 because version 2 is more readable, it's more direct. So if you want to use call by reference, I will suggest version 2 is better because it is more readable. We already introduced, you can use the new operator to allocate memory space. And if you want to initialize this integer, you can add a parenthesis after the data type. And you can also allocate other variable. You can also allocate other data type. For example, your own data type. And later we will learn how to define our own data type in later chapters. Next, we will discuss about dynamic and automatic variable. Dynamic variables are created with the new operator, while automatical variables refer to local variables. We already learned local variables. When you define a function, if you declare a variable inside that function, then that variable is local to that function. And local variables are created when the function is called, and will be automatically destroyed when the function finishes. So local variables are also called automatic variables. While for dynamic variables, we need to manually allocate and manually destroy dynamic variables. Sorry. So here is one example. We use the new to allocate memory space. And if you want to return the memory, you can use the delete operator. This delete operator will return the memory you allocated. If you don't perform delete, then the memory space will never return to the operation system, and this will cause maybe memory leak. So if you manually allocate some memory space, you need to remember to return the allocated memory. Otherwise, your program will cause memory leak. Your program will exhaust all the memory in your operation system. And when we allocate memory space, we consume memory from some space called heap or called free store. If there is no sufficient memory in heap, then the new will be failed. So if you require more memory than heap, then the new operator will return some error message. I will show you some example. Suppose we here I want to allocate many elements, many integer elements. Suppose I want to here I use bracket, not parentheses. This means I want to allocate integer array. So suppose I want to allocate 100 elements, 100 integers. Then you can use this. You use this syntax. So the S equal is 0. This means the function successfully terminated, and you can try to increase the number of elements. So suppose I use a large element, a large number. and you see that when you require memory space larger than heap, then the program will terminate it because this operator will throw an exception, bad allocation. This is a C++ exception. Means this new operator fails to allocate memory because I require a large number of elements. I think we can stop here, and the class can dismiss.